All right, so here we're going to look at 2021 AP Calc AB FRQ number 4. This is a very consistent problem. The type of problem here, if you look at pretty much any past AP test, you can guarantee there's going to be one problem on the FRQ that's like this. So this says let f be a continuous function defined on the closed interval from -4 to 6. It says the graph consisting of 4 line segments is shown above. Let g be the function defined by g of x equals the integral from 0 to x of f of x, or sorry, f of t dt. We can go ahead anytime that you see this and make the note that by the fundamental theorem of calculus, g prime of x has to be equal to f of x. And I think this is a good thing to write because this immediately tells you, hey, I'm currently looking at the derivative of g of x. Okay, so if you can make that connection, kind of unlocks quite a few of these other problems. So let's start out by taking a look here at letter A. It says on what intervals is the graph of g concave up? Give a reason for your answer. Well, here's what we know so far. We know that we have this function g of x, okay, and we know that the derivative of g of x is f of x, which means that the second derivative of g of x would have to be equal to the first derivative of f of x, okay? And so in order for a function to be concave down, this means that the second derivative, or sorry, in order for a function to be concave up, second derivative has to be positive, okay? So a function is concave up when the second derivative is greater than 0. Well, since we're already looking at the first derivative, what that means is in order for the second derivative to be positive, the first derivative, which is f of x, needs to be increasing. Okay, because if the first derivative is increasing, then that means when we take the derivative of that, we would get something that's positive, which means in this case, the second derivative would be positive. So in this case, we are just looking for intervals in which the derivative function that we're looking at, f of x, is increasing. So that would be from -4 to -2, okay? And then again from 2 to 6. So we could say we are concave up on these intervals because on these intervals, f of x is increasing. Okay, f of x is increasing, all right? Okay, over to the next one. It says let p be the function defined by p of x equals g of x times f of x, and it wants us to find p prime of 3. Well, we'll worry about the graph here in just a moment. I'm going to begin by finding the derivative of this function, and I'm going to use the product rule to make that happen. Okay, so product rule here says I like to do first times the derivative of the second plus the second times the derivative of the first. Okay, and then from here, everywhere that I see an x, I'm going to plug in a 3. So this is going to be p prime of 3. So this will be g of 3 times f prime of 3 plus f of 3 times g prime of 3. Let's see if there's any that I can go ahead and plug in pretty quickly here. I'll actually take this picture and probably move it over as we do each problem. So I can make this a little bit smaller so I can zoom in further and still see all of it. Okay, so let's start out with f prime of 3. So f prime of 3 is going to be the derivative of what we're looking at 3. Well, this is a line segment, so this is just going to be whatever the slope of the line segment is here. We can see that this line segment is going up 1, over 1, up 1, over 1 consistently. So f prime of 3 is equal to 1. Okay. F of 3 is, let's see, f of 3 is -3. You can see that from the graph right here. Okay, so not too bad there. And if you make the connection from earlier that g prime of x is equal to f of x, well, these are actually the same thing. So g prime of 3 is also going to be -3. The only thing that we're going to have to do a little bit of math for is finding g of 3. So I'll go up here to do that math, but g of 3 is going to be equal to, based on the function they gave us earlier, area under the curve from 0 to, in this case, from 0 to 3 of f of t dt. So we really need to find the area under the curve right here. You'll notice that we actually have a positive triangle here and a negative triangle here that are equal sized. So those are going to cancel each other out, and really all we need is the area of this trapezoid right here. Okay, so the area of that trapezoid is going to be 1/2 height 1 plus height 2, so it's going to be 4 plus 3 times the base. Well, from 2 to 3, that's 1. Okay. However, this exists under the curve, so this is really going to be a negative right here. So when we're done, this gives me negative 7/2. So I'm going to go ahead and plug that in right here. And there's no need by AP guidelines for us to evaluate this any further. I've plugged in all the values, so I'm just going to go ahead and put brackets around that. And there is my final answer for that problem. Okay. All right. So there's letter B, not too bad, just a derivative function. We had to use the product rule to find a derivative. And then plug in some values. All right, on to letter C. It says find the limit as x approaches 2 of g of x divided by x squared minus 2x. Pretty much anytime they give us a limit problem like this, especially with a fraction on a free response, this is a good indication. I'm going to be thinking about using L'Hopital's rule. Okay, but I'll go ahead. Before I can use L'Hopital's rule, I do have to show why L'Hopital's rule applies, and the only time that L'Hopital's rule is going to apply is if we get an indeterminate form when we use direct substitution. So I would actually like to start by trying direct substitution with this. Okay, so I'm going to say, well, direct substitution will give me g of 2 divided by 2 squared minus 2 times 2. Well, I do know 2 squared minus 2 times 2 is 0, so that's looking good so far. I've already got a 0 on the bottom. If I want to find g of 2, well, I need to find the area under the curve from 0 to 2 of f of t dt. Okay, we just mentioned this on the last problem, but go ahead and move this over again. Sorry, excuse my formatting here. So if we think about the area under the curve from 0 to 2, I mentioned this a moment ago, there's a positive triangle here and then a negative triangle here that has the same size. Okay, so those are going to cancel each other out. So when I'm done, I'm actually going to get 0 for this. And so in this case, when I try direct substitution, I get an indeterminate form. Okay, so I'm going to make a note here, direct sub is indeterminate. Okay, therefore, I will use L'Hopital's rule. Okay, and as we know, L'Hopital's rule says that the limit as x approaches 2, as long as we got an indeterminate form the first time, now we can take the derivatives of these and say g prime of x, take the derivative of the top and bottom individually. G prime of x divided by derivative of x squared minus 2x is 2x minus 2. And now we can try direct substitution again. Okay, so now let's try this again and see what we get. So we get g prime of 2 divided by 2 times 2 minus 2. So the bottom of this, that's 4 minus 2, that's going to be 2. G prime of 2 is just going to be, well, remember we talked about earlier, g prime of x is f of x. So when I come over here and look at the graph, if I want to find g prime of 2, I'm really just looking for f of 2, and I can see on the graph here that that is negative 4. You could leave it like that, or you could say, well, that is negative 2. So there we are evaluating this limit, okay? All right, on to the last problem here. It says find the average rate of change of g on the interval from negative 4 to 2. It says, does the mean value theorem guarantee a value c from negative 4 to 2 for which g prime of c is equal to this average rate of change? Justify your answer. Well, before I'm even going to worry about the last part, I'm going to start by seeing if I can find the average rate of change from negative 4 to 2. So in order to do that, I'm going to need to evaluate g of negative 4 and g of 2. We actually just evaluated g of 2 in the last problem and got 0. To evaluate g of negative 4, well, we're going to go from 0 to negative 4 of f of t dt. Okay, making a note here, these bounds of integration are flipped, so I'm going to flip them back. So whatever answer I get here, I really need to make it negative. And let's see what we get when we do some analysis here with this graph. Okay, we need to find the area under the curve here from 0 back to negative 4. Okay, so I've got a couple different shapes right here. I can do a triangle here. Okay, so 1/2 base times height. 1/2 -4 to 2, base is 2, height is 6. Okay, so that's going to be 6. And then this other shape here is a trapezoid. So I'm going to go 1/2 height 1, so that's 6 plus 4, and from -2 to 0 is 2. 1/2 and the 2 cancel out, so I get 6 plus 10. So that's 16, but don't forget about this negative here. So really it's -16, okay? So basically what we have here is we're trying to find the average rate of change from -4, -16 to 2, 0, okay? And average rate of change, remember, is just a slope. Okay, so the average rate of change here is going to be, we'll go 0 minus -16 divided by 2 minus -4. So that's 16 over 6, which is fine. Or you could say 8/3 if you'd like. And once note, does the mean value theorem guarantee a value C for which G prime of C is equal to this average rate of change? Okay, in order to use the mean value theorem, okay, G of X needs to be differentiable over the interval. Okay. Well, here's the thing. The thing that we're currently looking at is f of x, and since f of x is continuous, in other words, it doesn't have any breaks, gaps, or anything like that, we know that g of x has to be differentiable. Okay. Because in order to be differentiable, it means the derivative exists at every place, and we can see that f of x exists everywhere. Okay, and so f of x is continuous. So we can say since f of x is continuous, g of x is differentiable over the interval. Okay, and since g of x is differentiable over the interval, this means the mean value theorem does apply. Okay, so we could say therefore mean value theorem applies, and g prime of c equals 8/3 for some c value within the interval. Okay, kind of a tricky problem in the sense that you have to make that connection between f of x being continuous and that meaning that g of x is differentiable, but not anything that's too impossible to think about as long as we understand differentiability and continuity. And that concludes question 4 from the 2021 AP FRQ.